Hi everyone, I wanted to talk to you a little bit about more inequalities that are covered in 11.8 but not really to a very good extent. And this is on polynomial inequalities, so everything that you learned about quadratic inequalities can be extended to this type. The only difference is really these have more than two factors, so the degree of the polynomial is 3 or higher. The only ones that you need to know how to do are the ones that are factorable. So as an example, here's one that's factored. It is the polynomial x minus 2 times x plus 3 times x minus that expressed less than 0. So we'll start by doing the same thing that we did with quadratic inequalities. We're going to start by replacing the inequality with an equal sign and solving. Since this is already factored, do not undo the multiplication. That will make it a really hideous problem for you. So you just want to set those factors equal to 0 and solve. So we have where x minus 2 is equal to 0, and if we add 2 to both sides, we get x is equal to 2. Where x plus 3 is equal to 0, we can subtract 3 from both sides to get x is equal to negative 3. And the last factor, x minus 5 is equal to 0, we add 5 to get x equal to 5. Now I'm going to follow this with the method that I showed you on the last video. That is to use a graphing calculator to find out where the graph is above or below the x-axis. So what I've done for you here is I've shown you the graph of that polynomial y is equal to x minus 2 times x plus 3 times x minus 5. Now it looks a little bit weird. We haven't really gotten into graphing polynomial inequalities. You'll do that in a later course. But the main thing that I want to show you is that the x-intercepts are those solutions that we just found. That is what? This is negative over here. This x-intercept point is 2. And then we also have an x-intercept point of 5. And so notice that these x-intercepts divide the number line up into different regions. We have a region A, which is to the left of negative 3. And we have a region B that is between the negative 3 and 2. And then we have region C, between the 2 and the 5. And then the last region is, which is to the right of 5. Now, what we were trying to find here are points that, or that is these values that make the graph less than 0. So we're trying to find where is y less than 0. And if you remember, y less than 0 for that lie below x-axis. So if we look at our graph, regions of points are below the x-axis. I know I cluttered this up, but would you agree the portion that is to the left of that negative 3 was below the axis? And also 2 and the 5 are below the x-axis. That corresponds to A and C. So what we would do is answer with those intervals for regions A and C. So the solutions is everything of negative 3, which is negative infinity to 3. Everything that is between 2 and 5, so that is 2, 5. Parentheses are used because we're not allowed to include those endpoints. That is, we cannot include where y is equal to 0, so we have to use parentheses. I'm going to show you one other way to present the solution is on a number line. So if on a final exam or in my math lab solution on a number line, basically what you do is plot. I made a mistake there. That was negative 3. You plot the solutions to the equation, that is, this negative 3, 2, and 5. The line is going to show a shaded region that represents solutions to inequality. Since we know regions A and C made inequality true, on this number line, those regions, so region A and C. Parentheses, because we're not allowed those in our solution. Okay. So if you're asked to enter with the interval that we just talked about. And if you're asked to answer with a graph, you would do this. Last example. This time we want to solve the inequality x minus 4, x plus 6 is greater than or equal to 0. That is x minus 4 is equal to 0. Adding gives us 4. 1 is equal to 0. Subtract 1 to get x equals negative 1. Or x plus 6 equal to 0. Subtract 6 to x is equal to 6. So we have 3 solutions to this polynomial equation. Now we're going to graph. Y is equal to x minus 4 times x plus 1, x plus 6. I have this graph already drawn here. All I did is on the calculator input in the y equals this equation and press graph. Notice that x-intercepts correspond to those solutions. That is negative 6. What is it? Negative 1. And then the last one over here is 4. Let me make it look a little bit neater. Okay. So again, we have some regions that are formed. We have a region to the left of this negative 6. We have a region between 6 and negative 1. A region between negative 1 and 4. And then a region to the right of 4. So 4 regions, A, B, C, and D. Now what were we trying to find? We're trying to find x minus 4 times x plus 1 times x plus 6 is greater than or equal to 0. Remember, this is just our name for y. So we're trying to find where is y greater or equal to 0. Well, remember what y being greater than 0 means. Y to be greater than 0, that's the points that lie above the axis. And for y to 0, those are points that lie on the axis. Look back at this graph and find what region of points make the graph above the x-axis. Well, looks like region B, even though it's off our screen, we have to do some maximum point down. Region C, like it's below, and D, it continues to be above the x-axis again. Only in B and D do we have solutions. So above the x-axis is in D. To be on the x-axis means that we get to an endpoint, so we're going to use our brackets. So our solution, that is 3, the interval that regions. So region B is between negative 6 and negative 1, but since we can include those endpoints, we use brackets. Negative 6, 1. And union region D, which is to the right of 4, so that's a bracket, 4 to infinity. And then just last thing, the alternate, we see the solution is by graphing on a number. So if you were to plot those solutions, negative 6, negative 1, you would need to shade the appropriates on this line that correspond to the solutions. And we already know that those are regions B and D. So I'm going to shade region and shade region. And so I use the bracket. And so my solution is this.